All right, this is Sparks Pre-Calculus. We are on day number 8. And today we're going to talk about composition of functions, and we're going to look at it numerically, graphically, and analytically. So let's dive in. We have a table here with values for f of x, g of x, and h of x for select x values. And so we're going to go ahead and use that. Let's see. Let me find a pen. So this says -3 times h of 0. H of 0 is 0. H is 2 times 2. And then times g of -3. G of -3 is right there. And we calculate that and we end up with 12. Not too tough. Let's do it again. 2 times g of -1, that's 7. Over f of -2, f of -2 is 3, which gives us 14/3. Go ahead and try C on your own. You might want to pause this so you can check your answer. The answer is 20. So this notation looks a little different. This says h times f of 2. This is the same as h of 2 times f of 2. Go ahead and calculate that one. I'll give you the answer, so you might want to pause this. And I get 0. So now this notation, this says we're going to do h, but first we have to figure out f of 2. F of 2 goes inside of h. So this is h of f of 2 is 3. So h of 3. Then we go down to h and we find h of 3 and then we get -1. Let's try that again. So we have to figure out what f of -3 is, and then we're going to plug this answer in to g. So f of -3 is 0. So we plug 0 into g, and g of 0 equals -2. You go ahead and try g, h, and I, and let's compare our answers. You may want to pause this right now. G, -3, H, 5, I, 0. I'm going to do J and then let you do K and L. So notice this time we have 3 functions. So we're going to start with the inside and we're going to find f of 2. So f of 2 is 3. Then we're going to plug 3 into G. So we have G of 3. And G of 3 is -3. And then we plug -3 into h. H of -3 and h of -3 is equal to 1/2. You try K and L all by yourself. K is -2 and L is -3. Kind of funny, L, because you plugged it into G, then F, and then back into G again. I thought that was kind of interesting. Especially because we got out -3, and that's what we put in. Huh. Let's take a look at M here. K of x is equal to 2x plus 10, and we want to know what values of x make k of x equal to f of g of h of -1. So let's start with finding out what f of g of h of -1 is. So we start with h of -1, and looking back up at that chart, that equals 1. And then we plug 1 into g, and g of 1 is equal to 0. And then we plug 0 into f, and we get out -4. So this is equal to -4. So we want k of x to be equal to -4, but k of x is also equal to 2x plus 10. And so now we're going to solve this to figure out what x values make this true. So we subtract 10, we get -14. Divide by 2, x equals -7. So you go ahead and try the same idea with this one, but remember that the absolute value of 2x minus 3, you're going to set equal to whatever value you get, a, and also set it equal to -a so you can get both answers. And finishing this, we end up with x equals -1/2 and x equals 7/2. Next page. Alright, so I'm going to do the first one, and then I'm going to let you do most of these. So I have negative 3 f of 2 plus g of negative 3. So let's see, f of 2 is up here at 2. So we have negative 3 times 2 plus g of negative 3, which is here, so we're down at negative 2. And we end up with negative 6 minus 2, which is negative 8. So you can check your answers, but you should pause it right now and do these problems. I'm going to do all the way through L. When you pause it, and then I'll give you the answer all the way through L, and then come back and we'll look at M and N. Here you go. Here are the answers. I'll put a box around them. And then let's take a look at M. So we want to know when h of x, which is x squared minus x, is equal to g of f of negative 1. So g of f of g of f of positive 1. So we could find f of 1, which is 0, and then we can find g of that value, which is 2. And we want to know when h of x, which is x squared minus x, is equal to 2. So this is a quadratic, so we're going to have to set this equal to 0. So I subtract 2 from both sides. X squared minus x minus 2 equals 0. This one factors. So we know that x has to equal negative 1 or x equals 2. You try n on your own. You should pause it right now because I'm going to go through the solution. This one has no solution. When we come down to it, the absolute value of anything can never be less than 0. Therefore, no solution. Next page. Alright, on this page, I'm going to let you do 1, 2, and 3. You should pause it and see what you get. Alright, g of h of 4 is negative 7. F of negative 2 plus p of 2 is negative 19. And then p of g of negative 1 is undefined because we end up with 0 in the denominator. So this time, we're going to go ahead and find f of g of negative 2 just like we did, and then we're going to continue with that problem and do something else. So please find f of g of negative 2 right now. You can pause it, and then you will see what I get. G of negative 2 is negative 3. F of negative 3 is 29. But task 2 is slightly different, where we're asked to find f of g of x. So we're not going to be able to plug in nice, neat numbers to do this. We're going to take g of x, because that's what it's equal to, just like we did g of negative 2 and got negative 3. This time g of x is equal to 2x plus 1, and we're going to plug that in for all our x values. So it's f of g, but g is really 2x plus 1, and that's equal to 2 times 2x plus 1 squared minus 3 times x, which is 2x plus 1, plus 2, and then we would need to simplify this a bit. 2 times 2x plus 1 squared is 4x squared plus 4x plus 1 minus 6x minus 3 plus 2, 8x squared plus 8x plus 2 minus 6x minus 3 plus 2, and I get 8x squared plus 2x plus 1. So this is f of g of x, and this up here is f of g of negative 2. So let's verify that that works. So we're going to have f of g of x, which we know is equal to 8x squared plus 2x plus 1, and let's see if f of g of negative 2 gives us the same answer we got earlier. So 8 times negative 2 squared plus 2 times negative 2 plus 1. 8 times 4, 32 minus 4 plus 1, which is equal to 29, which is the same thing we got up here. On the next page, I'm going to do a couple of these and then let you check your answers. So g of h of x, so we have g of h, here's h, 3 halves x minus 2. That is equal to, here's g, 1 minus 2, and in place of x we're going to plug in the value we're looking for, which gives us 1 minus 3x plus 4, negative 3x plus 5. Alright, you do B, C, and D, and then we'll take a look at E. after we come back. So pause it now. And here's what I have for B, C, and D. Looks like that needs a box. Let's take a look at E. Find an equation for negative 6x times h of x minus f of x. So negative 6x times h of x, which is 3/2 x minus 2. And then we're going to subtract f of x, which is negative x squared plus 3x minus 5. If you want to pause it, I'm just going to give you the answer and simplify it. And that's what that looks like, completely simplified. So f, there's a little bit of notation here. This is equal to f of x times g of x, which you can go ahead and do that one on your own. And you can pause it right here. A little messy, but it's just basic algebra. For part I, we want f of x equal to g of x. So we have f of x, which is negative x squared plus 3x minus 5. And we want to know when that is equal to 1 minus 2x. This is a quadratic, so we're going to get everything on one side and set equal to 0. I prefer positive x squareds, so I'm going to move everything to the other side. And that'll give me x squared minus 3x plus 5 plus 1 minus 2x equals 0, which simplifies to x squared minus 5x plus 6 equals 0, which factors nicely. And we get 2 answers. I'm going to get you started on J here just because of the notation. It says g plus p of x. That is just g of x plus p of x notationally. I wasn't sure you'd know how that worked. All right, I'm going to call that one a day, and we'll see you next time.